right, welcome to WASA Distance Education. This is Mbf3C Grade 11 College Prep Math. I'm Keith, I'm your teacher, and this is the last class in our 9-week course. So what I'm going to do is just going to continue with the review. We'll certainly get through Unit 3 today. I'm kind of maybe giving Unit 4, the data management, a little bit of a pass on the review, just mainly because we just studied that just before we started the review, and I think we've kind of been over that quite a bit. Okay, so but I do want to talk about the things in Unit 3. That was the trigonometry. Okay, and the different things that we learned there. Okay, because this Unit 3, there were some pretty tricky parts to it. Don't worry so much about the exam. Remember, the exam is going to assess what you learned on the whole course. So there's going to be some questions on simple interest, some questions on compound interest, some opinion questions. Is it better to, buy a used car or a new car, or something like that? There are going to be some questions on SOHCAHTOA, right? The law of sines, a few on the law of cosine. So there'll be a variety of things. So don't stress out. If you're going through the exam, go through it, find the ones that you know you can solve, do those ones, and then go back and just try to do something on all the ones that you're maybe having a little harder time with. Okay, and that's a good strategy for any exam, but especially in math. Okay. So, and it's quite normal and typical that you just, you're going to get to a certain a point in the exam. There might be some stuff that you just can't quite remember, and that's fine, right? When you got to get worried is if you open it up and you don't recognize anything. But that's not going to be the case here, because I guarantee you all these questions just come straight from the key questions. They just, that's what it is. It's the key questions, and they use different numbers. Okay, maybe just a few slightly different way of phrasing it. Okay, so this is it. Now, I know that at least some of you are really making some good progress here, and what'll happen? You've got some time to wrap things up and then do the final exam. Okay, now if it's going to take you more than a couple weeks to wrap things up, then I really need to talk to you, and we'll kind of make a plan just so that we know that you're still making progress. Okay, and otherwise that'll be fine. And if you really can't do it like in the next couple weeks, it's fine. We have at least until the end of June to get everything wrapped up, but that would require just a little bit of paperwork. Okay, so that's where we're at. All right, just basically talk to me and let me know what you're doing, and I will help you. All right. So for lesson 11, we started out, and what we studied was SOHCAHTOA. So I know we looked at the sine ratio, the cosine ratio, the tangent ratio, but actually what I call that is SOHCAHTOA. And the way I remember it, SOHCAHTOA means I love triangles. Okay, so when you get your paper, you can write that on there. As a matter of fact, I'm pretty sure I put it in on the reference sheet somewhere. I put SOHCAHTOA on there. Okay, most people can remember it pretty well, but just in case you get nervous, I didn't want anyone to get nervous and then you forgot SOHCAHTOA. Okay, so SOHCAHTOA then will give us ways to solve right angle triangles. Now remember, SOHCAHTOA only applies to right triangles. That is a triangle that has a right angle in it, and that right angle has to be indicated with a little square. Okay, so we know that little square is going to be, as I show over here, that's going to be a right angle. And it doesn't matter if the triangle doesn't look like a right triangle, as long as it has that little square, then you can assume that it is. We know that the hypotenuse is the longest side of the right triangle, and that's always going to be opposite the right angle. So if you can imagine, if you were just kind of sitting there, you're just kind of sitting there on that right angle looking up, you would see the hypotenuse. Okay. Once you find the hypotenuse, then all you need to do is identify opposite and adjacent, but those change depending on which angle you're looking at. So in the case of angle A here, the opposite is going to be this side over here, This is the opposite. Whoops, opposite. I'll do that in blue. And then the adjacent is the side that touches uh, angle A. And so that's right there. Now, if we switch it around and do angle B here, and I'll make this in green, then the opposite's going to be across the triangle. Okay, the side that doesn't touch the angle is the opposite, and then the adjacent would be the one that does touch, that is adjacent, is next to the angle that we're looking at. Okay, so that's the thing to remember. They do change, and once you have that, you're pretty good. One of the things about triangles, the interior angles add up to 180 degrees. So, and that's all triangles. So if you're working with right triangles, you know that the one is 90 degrees. So then the other two, A plus B, the two other angles have to add up to just 90 degrees. Okay, I don't know if that really helps you or not. I always just think of it as they all add up to 180, and then I say I already know what one of them is. If you know what two of them are, then you actually can work out the third one fairly easily, just by adding up and subtracting that value from 180. Okay. Now the sine ratio, it's the SOH in SOHCAHTOA. So sine is opposite over hypotenuse. Okay. Now the sine of an angle is just a ratio of the two side lengths. Okay. But we can use that. We can actually use that in a couple of ways. Probably the best way is if we're trying to find an unknown side and we have an angle, then we can use sine. If we have the opposite or the hypotenuse and we're trying to find the other one, we can use the sine. Okay, your calculator can do the sine. Okay, and then you can solve for the unknown side, whether it be the opposite or the hypotenuse. Now they use x, right? You could always just call that, what are they trying to do here? You could call it HYP if you want, or even H, capital H. Just be careful getting in the habit of using little h, because when we get into a lot more geometry, and you know you'll be doing that certainly if you take the grade 12 version of this course, little h, we commonly use it for heights of things. So just keep in mind, try not to get in the habit of using little h for hypotenuse. Use capital H or HYP or something. It'll just help you down the road. Now, when you start this exam, make sure you have your scientific calculator. You're going to need it. Make sure that your scientific calculator is set to degrees mode, okay? Because otherwise you're going to get some rather dodgy looking angles. Okay, probably the easiest one to remember is that the sine of 45 is 0.707. You know, as kind of a rough thing. So you can double check your calculator that way. Okay. So you can solve problems related to the sine. Okay, and then the other thing that you can sometimes do, depending on the problem, is let's see, are they gonna actually give us this an example? Ah, yes. Okay. Yeah. So sometimes you're given the ratio, so you have all the sides you need, but you need the angle, and that's the nice thing about the SOHCAHTOA. If you're using right triangles, it's pretty easy to get the angles from the sides. Matter of fact, all you really need is a couple of sides, or a side and an angle in a right triangle, and then you're all set. And that's because you sort of by definition you get an extra angle. You know that you got one angle is 90 degrees. Okay, so remember that if we want to find an angle from the ratio, okay, so we need the opposite and the hypotenuse, or some of the other ones we need different sides. Once we get the ratio, then we have to take the inverse sine. Okay, and usually that's the a shifted version of the sine button on your calculator. Okay, and remember that sine has units. As a matter of fact, the only thing that doesn't have units in all of trigonometry are the actual ratios themselves. They're just a unitless ratio. It's a ratio. But once we start measuring lengths, once we start measuring angles, they all have units. The lengths will be given in whatever units are given: meters, centimeters, millimeters, feet, miles. And the angles in grade 11 math is going to be degrees. Okay. I'm not sure if they'll start talking about the other ways of measuring angles in grade 12, but certainly if you take any college math, there's a couple other ways. And, we use them because they're handy. Just some types of problems are just easier to do with a different measurement, right? It's just kind of like, for some things, you'll use your ruler, right? But if you want to measure your yard, you're going to go out and get a tape measure, right? And use that. It's a lot easier. That's the way we have things in math, right? We have our tools that are a little easier, some problems. So you've gone through all of these. Okay, so do watch those units because it's just easy marks to, keep, if you put the units in, even if you get the wrong answer, I'm still, pleased to see the units when I'm marking. Okay, so just do the best you can there. Right, so practice a few of those, you should be fine. Now, the cosine ratio is going to be exactly like the sine ratio. The difference is that the cos is going to be, it's SOHCAH, so it's SOH, CAH, and TOA. So the AH is adjacent over hypotenuse. You notice that the sine and the cos, they both use the hypotenuse, right? And the opposite and adjacent. Little other thing to think about here is that the hypotenuse is the largest side in the triangle, in the right triangle, which means that this opposite over h and adjacent over h will always be less than 1 because the denominator of that fraction, that ratio, is always going to be bigger than the numerator, right? The hypotenuse is always going to be bigger than the opposite, and it'll be bigger than the adjacent. Okay, so the only one that can be bigger than 1 is your tan ratio. Okay, so but as far as how you use the cosine ratio, it's the same, just you're using a different side. Okay. And if you want to find an angle from the ratio itself, then of course you're going to use the inverse cos, which is shown right here on page, where are we? Page 10. Okay. Now, if you're studying for the final exam and that you're going through it and there's something you don't understand, maybe you're reading through the notes I put in your assignments, or, maybe you can't, so feel free to contact me, right? It's easy to reach me, P.W. Wassa. Okay, you can send me an email. It's pwispansky, and then it's at nnec.on.ca. Double check the study guide for that. You can call me. Okay, that's a little trickier just because you never know. You through in my office hours I'll be in. But remember, our office hours are going to change next week because we start a new semester next week. So I'll be in, let's see, where's the best time? In the mornings and in the early afternoon starting next week. Okay. And then, of course, you can always use my cell phone number, text me. Again, that's another easy way to reach me. And yeah, I'll be happy to help you if you have some questions, go through it. Okay. All right, that's what I'm here for. Now, finally, we saw the tangent ratio, and that's the TOA in SOHCAH-TOA. And the tangent ratio is just a little different from the other two in that you're using the two sides. You're not using a hypotenuse. You still have to have a right triangle, though. It has to have a right angle in it. And it's interesting that if I'm looking at angle A, now this, I think this diagram on page, where was it? Diagram on page 12 is wrong. They actually had it pointing to the hypotenuse. So I fixed it here. So if you're looking at it in your book, you probably want to fix it. So the adjacent, the tangent is opposite over adjacent. So if you find the tangent ratio for A, if you think about it, the tangent ratio for B, of course, this is now the opposite, and this is the adjacent. So you'll notice that they're actually reciprocals. There's something, right? So if you have it for A, you hit the 1 over x button, that's your value, the tangent ratio for B. Just a little shortcut for you. All right. And let's see. I think that's about it. And use the tangent ratio the same way. Now, when you're going through the questions, if you see a right triangle, there's a very, very good chance that you're going to be using SOHCAHTOA. As a matter of fact, you should be trying to use SOHCAHTOA, because that's the easiest tool to use. But you may not necessarily know, especially in the exam, which ratio they want. Right here, it was pretty straightforward because they did a lot of sine, right? You knew it was sine, you knew it was cos, you knew it was tan, because that's what we were studying in each section. But on the exam, they're just going to give you a right angle, and then you have to figure out which one to use. Okay. So the best thing to do then is to make a diagram. Actually, it's the best thing to do anyway. You're going to make a diagram. That helps you a lot. That's good for a mark, usually at worst. Right? If you're trying to solve a trigonometry question and you write out a decent, reasonable diagram that reflects your understanding of the problem, at least you're going to get a mark for that question. Okay? Chances are that writing a diagram will help you understand what it is, right? Now, if you, here's the thing, right? Let's say you don't do the diagram, and then you put your solution down, and it just something goes wrong. It's really hard for me to figure out where how much right you were on the question, right? But if you have a diagram, even if your diagram isn't quite right, if it reflects what you understand about the question, then, like you say, that's good for some marks. Okay. All right. So now you're going to have these questions, and the questions on the exam would be not those like 1, 2, 3 type questions. It'll be a little more like question 4, like that, where you're just solving. Okay. And now if you get a word question like this, I suggest you go over these word questions. Okay. And something like this, like when I saw this, I didn't really point out that I was assuming it's a right triangle, and that's something that is important, right? If you're going to assume it's something's like calculate the measure of the guy wire in the ground supports a vertical power pole, right? So if you're assuming that that's a right triangle, then make sure you draw that in on your diagram. Okay, I actually messed up there back when I was showing that, because I just sort of forgot to put that in there. Let's see if I can make that a better arrow. All right. Okay. So you read through the question, try to write down what you kind of see in there on a diagram, and yeah, and then once you have everything organized in your diagram, you may actually be able to get a clue as to how to go about solving it, right? In this case, we want angle A. And what do they say? So it's 9.5 meters, 13.5 is the hypotenuse, and we know that that's the length of the guy wire. Okay. And what else did we? 8.7. Yeah. So they've given you actually all 3 sides of this triangle. So that's going to be relatively. Really, you have it made, because you could find angle A by any of the 3 ratios. If you think about it, right? The sine ratio, right, opposite over hypotenuse, the cos ratio, adjacent over hypotenuse, and the tangent ratio, opposite over adjacent. So yeah, that's, once you have it all written down, then it's just usually the way forward is pretty clear. Okay, but try those. Those are usually worth a few marks on the exam. And like I say, if you at least put your diagram and maybe a couple formulas down, you've sort of gone a long ways towards getting all of those marks. Okay. Yeah, so here's an example, question 9, where they're really not, there's no diagram that they give you, so it makes a lot of sense then to actually write a diagram. I kind of squeezed it in there, which is not the best. When you're doing that exam, I strongly suggest you have some paper, whatever paper you like. If you like plain paper, use plain paper. If you like lined paper, use lined paper. Okay, whichever you like. And just maybe make a little note on the margin that it's on a separate sheet. I mean, I will find it eventually, but sometimes I'll be marking along and it looks like a student has skipped the question, and then I don't find it until I get a little further in. So yeah, so make a diagram. You don't have to be super neat, just as long as it's readable. Okay, and mark down all your assumptions. All right, so I think we've pretty well covered a few of those. One of the things I'm going to go through the exam and double check, um, make sure that any diagrams that are presented in there match the questions, because sometimes I think the questions get changed and the diagrams don't. So we'll double check that. But in any case, if you do encounter that problem, I'm not gonna, whichever one you use will be fine, but it should be the words that are that's the correct information. So if the words can conflict with any diagram, just change the diagram to match the words. All right, and then one of these opinion questions, what I'm looking for in the opinion questions is um, it is your engagement with the course material, right? So it doesn't really matter. I mean, if you tell me that Takatoa is a dumb idea, that's fine as long as you can kind of make your case. Give me your opinion, explain why. Okay, I'm still going to give you the marks. Okay, just don't leave those blank just because it's got a bunch of words. Okay, these are relatively easy questions to get marks on, but a lot of students leave them blank once they see it's not a problem, it's more of an opinion. Tell me your opinion. Okay, I'm interested to know. All right, so once we get past the Sakatoa, once we're not looking at right angled triangles, then we have to bring in a bit more powerful tools. Now, one that's fairly easy is the sine law. Okay, so for a lot of triangles, we can take care of it with the sine law. The sine law is for any triangle, and it's written this way. You'll have that on your sheet. It's written as a ratio of either the sine of an angle over the length of the opposite side, or the inverse of that, right? The sides over the sines, and it doesn't matter which one you use as long as you're consistent. Okay, and the reason we would use different ones is if you're trying to find a side, then you're going to use the form that puts the sides in the numerator, and if you're trying to find an angle, you're going to use the one that puts the sine of the angle in the numerator, usually. And it just saves you from having to take the inverse of both sides at the end. If you did, right, if you did use the wrong one, you realized it at the end, you just take the inverse 1 over x of both sides, right? So, and you'd still be fine. All right. Now, they go into a fair bit of detail about when to use the sine law, but really, you could always just write it out on the side. Don't be afraid to do that. Like if you try, say, okay, sine law, and then you fill in the sine law and you realize that you don't have enough stuff to use it, just then, on the next line, then write out the cosine law. You don't have to explain to me that you tried the sine law and then, it didn't work. You don't have to erase it or anything. That is because this is the way we do math, right? We try things, and sometimes we got to sort of back away a little bit, or maybe the sine law would work, but you need to calculate something. So as long as, it's usually pretty clear from the question when I'm marking it. Okay. Okay. So there's different ways that you'll use the sine law. Let me back up a little bit here. Okay, so when can we use the sine law? Well, basically we need, for these ratios, we need one that has everything, okay, and then at least one that's opposite the thing we're trying to find. So if we're trying to find C, then we need either this one or this one to have both, and then we also need the side opposite what we're trying to find. So probably the one that's the most critical, the hardest, if you are asked for sine B, look to see if you have the opposite side. If you don't, then you're probably not going to be using the sine law, because there's no other way to proceed with it. Okay, but if you have both, if you're looking for the sine of an angle and you do have the opposite, that's a good sign that you can use the sine law. Good sign? You can use the sine law, maybe. Okay. But as I say, don't worry. Try it out. Plug some numbers in, and then if you can't use it, you could even write it down on the side. Can't use it, but if you just kind of plug the numbers in and then start using the cosine law, that'll tell me that you recognize you didn't have enough stuff. Okay. Yeah. Unlike some other, you know, in chemistry, if you mix the wrong chemicals together and everyone starts running and you know, there's smoke and it's terrible. But in math, if you use the wrong formula, nothing happens. You just then just on the next line you use the right formula. So it's a much easier subject in that sense. Okay, so we have a support questions, and remember the answers to these are at the back, so you can go give those a try. You know, make sure you study these word problems, try a few of them, and make sure you can get them because that will really help you for the exam. There's a few of those word problems on there. Okay, and looks like I tried those. Whoa, hey. I think we also did a review as well, in addition to going through the unit. I think we went back and did a review, so there's a lot of material there. Okay, you can always go back to the tapes as well, or the YouTube videos, or the archive to watch the archive and re-watch those lessons. Now, this question, yeah, this question was, to be honest with you, a little bit dodgy because they don't really talk about that. Um, I, I don't really see this being an issue on the final exam, but yeah. And see, in this case, it's not even angle, it's side. I don't know how that slipped by. Whoops, side. I know how to spell side. I don't know. Okay, let's try. Yeah, unknown side. Right, so these are pretty lousy questions. I'm probably going to change them for next time. So sorry about that. I wasn't really too picky on the marking of those either. They're just basically trying to get you to have an intuitive sense, right? Because this number, the ratio of these two, has to be similar to the ratio of those two, right? So if this number is much smaller, then this one then, because this number is smaller than that number, then to keep the ratios the same, this one has to be much larger. It has to be about twice as large as this one. Let's see. That's basically what they're trying to get you to do, but they didn't really explain that in the course material. All right. So, all right. So for all of these, then you know you're going to be using the law of sines. So it kind of narrows things down. The thing is, on the exam, it's not going to be as clear. They're just going to give you a triangle, and you're not in the law of sines unit. You're in the final exam where it could be SOHCAHTOA, it could be law of sines, it could be law of cosines. Okay. All right. And for number 9, I don't think anything like that on the final exam, but it's worth reading it over anyway, because that type of problem solving, there are some problems like that, you know, that type of problem. Yeah, and if you sent that question in, and you had some problems with it, you'll see that I put some notes in your on your assignment. Okay, and here you go. There's another one. Does the sine law apply to right triangles? Okay, I suggested as a little hint that you try checking the sine of 90 degrees and see what happens there. Okay. All right. Yeah, that's the rafter question. Okay, so after the law of sines, then we came up with law of cosines, which is the the kryptonite. I don't know if you'll follow. Was it Superman? He's nothing can harm Superman, right, except kryptonite. So I call it law of cosines the kryptonite of trigonometry, because if you can't solve it with the SOHCAHTOA and you can't solve it with the law of sines, you can certainly solve it with the law of cosines, if it can be solved at all. So that's why I call it the kryptonite. But it's a little harder, right? A little more dangerous to use. There's a bit more stuff to work out. Okay. So here's an example. To sort of show you. It's used to find the third side of a triangle when you have two sides and an angle, right? Or if you have three sides. So that's something the law of sines can't help you if you just have three sides, because you need at least one angle. Okay. And depending on what two sides you have, the law of sines may not be able to help you there either. Okay. So in a case like this, for example, this triangle BC, and we're trying to find x. So if we were going to use the law of sines, it would be x over the sine of 100 degrees equals, and now it's going to have to be 30 over, right, 30 meters over sine b, and okay, that's not going to work because we don't have b, or 50 over the sine of a. And we don't have that one, and we don't have that one, which means now we can't use the law of sines. Okay? So now it's time to go to the kryptonite, the law of cosines. The law of cosines will always get us this. Now, I've been trying to sort of, it looks a lot like the Pythagorean theorem, because really it is. If you have a 90-degree angle, that cos is going to end up being, it's not going to be in the final thing. You're going to get 0 out of that. So that last term disappears in a right triangle. So this is where you see it as the Pythagorean theorem is a special case of the law of cosines. Anyway, for something like this, I know that they like to say, they say c squared, b squared, a squared, but I just prefer to do it with the kind of the pattern, right? So in the case of what we're trying to solve here, it's x squared, because that's the side we're looking for, and then it's the square of the other two sides. 30 squared plus 50 squared minus 2 times the other two sides, and then cos the angle opposite the side we're trying to find. Okay, there you go. So that's how you would work that out. So notice I didn't have to figure out which one of these I'm going to use. I just wrote out the pattern, right? The square of the side that I'm looking for, that I want to find, equals the sum of the squares of the other two sides, which is right out of the Pythagorean theorem, and then minus 2 times the other two sides times the cosine of the angle opposite the side I'm looking for. All right, but the final exam does give you all three of these, so if you really want to have that and do it that way, then it's there for you. Okay. All right, example 1 tells us to use the cosine law. So again, this is one where we didn't have to figure out whether the sine law would work or not, but if you look at it, can we use the sine law in this? Okay, so they want us to find a. If we were using the sine law, it would be a over sine of 118 degrees equals, and then it's going to be 11 over sine c, or 16 over sine b, and in either case we don't have sine a here, sine c or sine b, so we can't use the law of sines. Okay, can't use that, can't use that. Okay. So if you were to write that down in your exam and it looked something like that, and then the next line was the law of cosines, that would be plenty to let me know that you are on the right track. Okay, this trying the law of sines at the beginning of it is not an error. Okay, it's a valid step in the 4-step problem solving model. Okay, you're understanding a problem, step 1. Step 2 is devising a plan. That's step 2 right there. Okay. All right. So I think that'll be good. Round things off to whatever makes sense. These are whole units. Round things off to 1 or 2 decimal places. Actually, the exam may tell you right in the first page how many decimal places to use, so just follow that as well. Okay. Now, in the case of this, you're going to find angle A using the cosine law. In this case, we have to rearrange the formula, okay, to isolate cosine of A. Okay, so we did that from first principles in the during the course material. Let me take a look at the. Just want to. Okay. Just want to take a look at the formula reference sheet. think that's it right there. Okay. Just to see which ones I give you here. Okay, so yeah, so you don't get the version where it isolates the cosine, so you'll have to work that one out yourself if you haven't memorized it. Okay, and yeah, because that's kind of part of the, um, part of working it, right? So let's take a look at the next page. This is how it works. We actually wrote out the formula here, okay? And then we just manipulated things. We moved the b plus c squared over and subtracted it basically from both sides. Okay. Then I multiplied both sides by -1 just to get rid of the -1 in front of that. I could have actually done it a different way. Could have divided both sides by -2 and that would have worked. But I think I was just going step by step. So in this next one, where is it here? I did divide both sides. Okay, I just did some rearrangement here, and then I divided both sides by 2bc, which is, oh yeah, okay, I made a mistake here. And that isolated cos A. Okay, now I would have just probably left this in this order right here, but the book does it. They get rid of that negative sign, so that's why I put the -a. But when you're adding or subtracting terms, it doesn't matter where they are. So moving that -a squared from the front of the expression to the back didn't change anything. It just made it look nicer to, I guess, whoever was writing the course material. Okay, so yeah, and it is typical. If you have a choice, you would not put a negative sign at the beginning. Okay, so once you rearrange it, then this is what it's going to look like pretty well all the time. Okay, so you may even be able to kind of work out this pattern because it is not, it sort of follows a little bit the patterns in the, where you're trying to find the side. Okay, so once you find that, then you're able to work out the angle given 3 sides because you're going to need 3 sides. And then when you get to this part, you're going to use the inverse cos function to find your angle. Okay, don't forget the units because you are working out an angle here. All right. So yeah, so take a look at those. Those are kind of some tricky problems, but they're usually worth a few marks. So you can give those a try. Okay, lots and lots. Now, when you're dealing with some problems, they sort of assume some knowledge that they don't necessarily give you. This is the bottom of page 30. So I just want to point something like this. Question 9, plane flies due east. Okay, so yeah, and I actually drew the little compass heading here. What they're saying is that the plane, if you put the directions of the compass on a Cartesian plane on an XY plane, then due east is going to be straight along the x-axis here. Okay. Second plane flies 40 degrees southeast, right? And so you can, what do I have here? Did I get that wrong in the original question? Due east. Second plane flies in direction 40 degrees southeast. Oh yeah, okay. Yeah, I don't know. I can't really read my writing, but anyway, that's southeast right there. How far apart are the planes when they reach their destination? Okay, so anyway, that sort of gives us an idea of how to solve something like that. You have to make some assumptions sometimes when you're reading these questions, and if you're not sure, write what your assumption is. Right? You can say, I assume that I assume east looks like this. Okay, and that'll be fine. Okay. Oh yes, the infamous baseball diamond problem. Okay. All right. So try a few of those. Now this one, lesson 14, and I'm glad we're getting a chance to talk about this one. This one was tricky because now they're not telling you which of your tools to use. Right? It's entirely up to you. SOHCAHTOA, law of sines, law of cosines, or well, that's it. So this is what you'll be be working on. So a diagram is going to be essential, and you know, you can always write down what you're assuming, but sometimes it can be a little bit, um, yeah, a little bit tricky, right? So an example here from a point halfway between the two poles. Okay, so they described a situation where the poles were 2 meters apart, and then they talked about halfway between the two poles. So now you know that you can assume that each leg of that triangle then is 100 meters. But some of the questions, you can't assume that. They don't say anything about halfway. They'll say a tower is between two poles and the angle of depression is this or that, and the poles are separated by a certain distance, but they never tell you that the tower's in the middle. And so you have to be careful when you're reading that any assumption you make is justified. Okay, and in any case, you can write it down. Okay, so at least if I know that you made an assumption, even if it's not really supported by the description, at least I'll know, you know, how you ended up with your solution. Okay. All right. So in this case, you just you have two things to solve. I think they're going to ask for the poles. So again, that's where when you read your question, you're trying to understand the question. When you're developing your strategy to solve it, make yourself a little note somewhere that you have two parts of it to solve for something like this, because it's very easy to get to that final answer and then forget to do the other one. Or what I see quite a bit when I'm marking is that they have to find a length and then they have to find an angle, and they'll stop when they found the length because they forgot that wasn't the goal. That was just a middle kind of step. Okay. And yeah, so we talked about our tooth, which I'm not really sure what kind of tooth it was. Okay, and you know, some of these questions are fairly complicated. You might need more than one diagram, but it is well worth it because they're usually big point questions. They're usually 5 marks, something like that, if there's a lot going on. Okay, so and remember, a couple of marks just for your diagram, a good diagram, and you know, maybe some sort of hint as to what your process would be. Okay. All right, and okay. So that's going to be the rafter. Okay, here's an example. This is key question 14, page 36. So this was an example of one where we were told that, well, I'll just read it and we'll talk about it. From an observation tower that overlooks a small lake, the angles of depression of point A on one side of the lake and point B on the opposite side of the lake are 7 degrees and 13 degrees respectively. Okay. The points and the tower are in the same vertical plane. Okay. And the distance from A to B is 1 kilometer. Determine the heights of the tower. Okay. All right. So what they're saying, the same vertical plane, that's just so that you can understand that this line goes through the points that they're looking at, right? And that when the person is standing in the observation tower and looking down from a point that's exactly the same height as the person is standing, as the tower, then that angle of depression is measured at 7 degrees. Okay, now that's, you know, how they would get that, I'm not really sure, but that's the scenario. Now, nothing in there lets you say that the tower that you're measuring, which is the observation tower, nothing in there tells you that it is halfway between A and B. Okay, nothing tells you that. So it would be, and as a matter of fact, you know that it really can't be midway because the angle of depression on one side, 7 degrees, 13 degrees on the other side. So it might be close to the middle, but unless those two angles were the same, then you could could probably say, well, yeah, it must be in the middle because both angles are the same. But if they're not the same, then chances are that the distance between A and B, 1 kilometer, but the observation tower is not 500 meters from A and B, that it's going to be, a bit further from one of them and a bit closer to the other. Okay. Now, there is something you can assume, though, which is not stated. Well, I think they show it on the diagram, but you can assume that the tower makes a right angle with the ground, right? And that's just sort of a common sense. It doesn't say that, but it didn't say, the leaning tower of Sioux Lookout, right? They're not calling it that, right? They're calling it an observation tower, and in our experience, observation towers are vertical. Same as walls. Walls make 90-degree angles with the ground. Poles make 90-degree angles with the ground. Okay, and towers, buildings, everything makes 90-degree angles with the ground. We can just assume that. Okay, so there you go. Okay, so question 3. This is an example of one where really that needs a diagram, right? Once you get your diagram, the size of the play area, measure 100 meters. It doesn't have to be accurate. Just draw a triangle, label one side 100, 250, 275 meters. Don't forget and now you need the area. Okay. Area equals 1/2 base times height. Now they're not telling you that, and I don't know that that's on the reference sheet, but that's the formula you're going to need. Now let's say that you've got that question, you just don't know the formula for area. Okay, that's fine, but you could certainly find the angles in the triangle, which you might actually need because you're going to have to kind of have a height. So the triangle is going to look something like that, 100 meters. Whoop. And let's see, 250, 250, and 275, right? So you need to actually work out. This is a fairly good, right? You need to work out a height right there. You have a base already. Now, why did I pick 100 as a base? It doesn't matter. I just picked 100. I could have picked any of them. You'll get the same result. Okay. But you have to work out the base, which means that you're going to have to work out a couple of angles. See, if you have that angle, and you know that side, then you're you can use your Pythagorean, or sorry, you can use your SOHCAHTOA on it, right? So this is a pretty rich question. It seems very simple, straightforward, but it is a pretty rich question. Okay, so just remember that area is 1/2 base times height for your triangles. Okay, I don't think, yeah, it's not on the sheet, so just one of those things. Okay, 4-step problem-solving model. This is probably a good way to kind of wrap up this this particular unit and this particular review. So I've been emphasizing this throughout the course. It's if you go on the internet and just type in 4-step problem-solving, or just 4-step problem-solving model, because I call it the model. That's the way they talk about it in Ontario and the Ontario curriculum documents, but it's also called a process sometimes. So just do 4-step problem solving. You'll see everything you want to know. You can read about it. Was a mathematician that came up with the idea. Well, there's a mathematician that kind of wrote it down, but basically what he did was wrote down what mathematicians had been doing, and scientists and even business people have been doing for years. So he just made it explicit. Understand the problem, so you read the question, underline some stuff. You might have to write a diagram at this stage. Your first diagram might not even be right? You'll refine your diagram. You might make a second diagram. That's understanding the problem. Then once you understand the problem, some things will pop out of that, which is maybe what tools you need to use. Right? Do I use the law of cosines? If I do, what angles do I need? Do I need to use a different law, maybe the Pythagorean theorem, to get something that's missing to plug into my law of cosine? That's your make a plan step. Okay, and for grade 11 math, those two are really usually the hardest part, and those are the parts that I put the most marks on, which is why I say make a diagram, write out some formulas, because that's step 1 and 2, the most important part. The carrying out a plan for grade 11 math is usually a calculator exercise. Usually you're plugging variables into a formula. It's important to be able to do that, but that's something that, it's less important than getting the problem, like heading in the right direction with the problem, right? Sometimes you go to type in 0.5 in your calculator and instead you type in 0.05, something like that. Not a big deal. Okay, not a lot of marks. And then the last part of the problem, which will help you a fair bit for any kind of problems that you're going to solve, is to look back. Okay, in teaching we call that reflective practice, where you taught a lesson or you finish the course and then you sit down and you think about it. How did I, what did I do well? What went really well? What went badly? Right? For the case of solving a problem like this, you're going to look at your result and you're going to say, does this look reasonable? Does this make sense? Right? I got a negative number for time. Maybe I should check go back and check. Right? Did I solve everything I was supposed to solve? Right? That'll catch those mistakes where you got part of the problem solved, but you didn't, it asked you to do one more thing, and you kind of forgot that. Okay, so that's a reflection. And then the other thing to look back on that and say, did I use the right formulas? I mean, you might have gotten the answer, but maybe there was an easier way to do it, less roundabout way to do it. And that sometimes happens, and that's how you get better, when you do that look back. All right, well, I think that's it for this review, and that's it for the course. So keep sending in your assignments, and just let me know how you're doing. If you're having trouble sending in the assignments, just let me know so we can make sure that you still get the credit. Okay, well, I'll work with you, and we'll come up with a plan. All right, well, thanks for attending the class, and we'll see you around. Bye now.